Hi everyone, this video is on the mixed exercise 9, the challenge question. And in this video, I'm going to do parts A and B, and I will do the other parts in the next video. Okay, so for part A, first of all, we are given a parametric, the curve C has parametric equations, and we want to find dy by dx in terms of t. So whenever we have parametric equations, in order to find dy by dx in terms of t, always we need this basically formula: dy by dx is equal to dy by dt over dx by dt. So that means we need to find dy by dt and dx dt first, and then find dy by dx. So for dy by dt, we differentiate 2 sine 2t. So first of all, 2t differentiates to 2, that 2 comes out, and we are going to have 2 times this 2 that is there. And then sine itself differentiates to cos. So it's going to be cos 2t. And it's going to be 4 cos 2t. And now for dx by dt, so we have 5 cos 10 plus pi over 12. Inside the bracket, differentiates to 1. So we are going to have 5 here, it doesn't change. And then cos differentiates to minus sine. So it's going to be minus 5 sine t plus pi over 12. Right, now we can find dy by dx, which is just dy by dt divided by dx by dt, and that's going to be 4 cos 2t over minus 5 sine t plus pi over 12. Okay, so that's the derivative and the answer to part A. For part B, we want to find the coordinates of the points on C where dy by dx is equal to 0. Basically telling us to find the coordinates of the stationary points. And in order to find that, we first need to solve the equation dy by dx is equal to 0. So we first solve dy by dx is equal to 0, which means minus, or we can just get rid of the minus immediately, because we are going to do cross multiplication. So 4 cos 2t over minus 5 sine t plus pi over 12 is equal to 0. And by cross multiplication, we are going to get 4 cos 2t is equal to 0. And we can get rid of 4. So just to have cos 2t is equal to 0. And let's just go back and see what are the range of possible values of t. So t is between 0 and 2 pi. Okay. So now in order to solve this, we first find the principal value of cos inverse 0. So it's going to be 2t is equal to cos inverse 0. So that's pi over 2. And we need to keep going because the next value that its cos is going to be 0 is 3 pi over 2. And remember, since here we have 2t, so the range of the values for t, for the solution to the equation changes because when it's 2t, we multiply everything by 2. So it's going to be 0, 2t, 4 pi. So we find the solutions up to 4 pi. And then once we have found all the solutions, we divide all of them by 2 just to go back into having t, not 2t. So we need to keep going. So these solutions are up to just 2 pi, but we need to have one more full cycle to get to 4 pi. So the next one is going to be 5 pi over 2. And finally is 7 pi over 2. So that's the last solution. Okay, now in order to have t, we divide all of them by 2. So it's going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi by 4. Okay, so now these are the solutions of t, but in order to find the stationary points, since we have parametric equations, for each of the values of t, we need to finding the corresponding x and y coordinates. So we first need to basically substitute each values of t into the equations of x and y to get the corresponding x and y coordinates, and with that way we can find all the coordinates of the stationary points. So the first value for t we can start with is when t is equal to pi over 4. Now, in that case, the value of x is going to be, the x coordinate is going to be minus 5 pi root 3 over 2. Again, we just substitute pi over 4 into the equation of x and then into the equation of y. And we repeat this for each of the values of t to get the corresponding x and y coordinates. Okay. And now that we have the x coordinate, now let's find the y coordinate when t is equal to pi over 4. And the y coordinate is going to be just minus 2. So these are, all just calculator work. So I'm just writing down the solutions. So this means that one of the stationary points is going to be minus 5 root 3 over 2 and then minus 2. Okay. Now the next stationary point is when t is equal to 3 pi by 4. And in that case, its x coordinate is going to be, I'm sorry guys, I made a mistake here because these values of x and y that I wrote, we get them when t is equal to 3 pi by 4. Yeah, but then let's see what values we are going to get when t is equal to pi over 4. Again, it just calculated work, so I read the wrong values. So when t is equal to pi over 4, then x is equal to 5 over 2, and then y is equal to 2. So the point is going to be 5 over 2 and 2. Okay. Now the next one is when t is equal to 5 pi by 4. So in that case, x is equal to minus 5 over 2, and then y is equal to just 2. So the coordinate is minus 5 over 2 over 2. Sorry, minus 5 over 2 and 2. And finally, the last coordinate when y is equal to, t is equal to 7 pi over 4. In that case, x is equal to 5 root 3 over 2, and then y is equal to minus 2. So the coordinates are going to be 5 root 3 over 2 with minus 2. Okay, that's it for this video, and I'm going to do the next parts in the next video. Thank you for watching.